The programming process. By the end of this video, you should have a good idea about how to start new programming projects and have a sense for the steps typically followed by programmers as they build and deploy a new project. So here's the programming process. Step 1 is idea generation. Step 2 is planning. That may involve things like doing screen mock-ups on paper, flowcharts, pseudocode. In step 3, you'll want to document your project as you are implementing it. And step 5, you'll debug your project and check for the quality of your project to make sure everything is working correctly. And finally, you can release and deploy your project. Let's start with step 1, idea generation. What makes for a good idea? Here are some tips. Uniqueness is not necessarily an important idea. The link on this slide points to an article, a blog article I read a while back that says that if you want to have a good business idea, you don't have to have a new or unique one. You can make $1 million with a McDonald's franchise as easily as you can with a new idea that no one has ever come up with before. So it's not necessarily the idea that makes the uniqueness of your idea that makes for a good project. It just has to be something that you care about. If you don't care about solving the problem, it's going to be a chore to implement. The link here on this one points to 37 Signals article on scratching your own itch and building software that you care about. You want to make sure that the scope of the project is feasible. Another hint here is to build less. When you're just starting out with software, determining whether or not your project is feasible is actually one of the harder things, since you don't have a lot of experience to go on. But that's something that will build over time as you have more experience with projects. So for example, my brother-in-law in Japan and I like to talk about cars. But one of the big problems we have, it's not easy for either of us to convert miles per gallon, which is how you calculate fuel efficiency in the US, to kilometers per liter, which is how you calculate it in Japan. So the solution in this case might be to build a simple program that will convert miles per gallon into kilometers per liter. So next is the planning phase. For graphical user interface programs, which is typically the Windows type applications that you're used to using, you want to start with screen mock-ups on paper. Why paper? First of all, using paper is much faster than using a computer. Typically, it'll take you, 10 seconds to a minute to scribble out a quick and dirty diagram on paper, whereas it might take you 10 minutes to do it on a computer. Another problem with doing it on the computer is you tend to get emotionally attached to design before it's really ready for prime time, and that can be a problem if you want to change that design later on down. With paper, it's really easy, on the other hand, to crumple it up and throw it in the trash can and start all over again. And also, with paper, it makes it easier to compare alternative designs side by side. So you can actually draw out 2 or 3 different options for the design, put them side by side, look at them yourself, show them to a friend, and get them to comment on which one is the easiest one to use. So I'm going to show you an example of mocking up our miles per gallon to kilometers per liter application on paper. Okay, so I'm just going to start by, for my miles per gallon to kilometers per liter calculator, I'm going to draw myself a basic form. I'm going to make it look, more or less like what I would expect to see on the computer. So I've got a button to close the program. I know that I need a place to enter the miles per gallon, so let's put a little label here and a text box where I can enter the miles per gallon. I also know that I want to end up with kilometers per liter, and so let's put a text box here. And I might want to put some instructions on here. Let's see. Let's put a button, first of all, that is going to allow me to do the conversion. Okay, and so say enter miles per gallon and press convert. And so I have some instructions. I have a basic interface. It does most things that I want. As I'm looking at this, it occurs to me that the way it's set up, if you go left to right, you can put in miles per gallon and hit convert, and it should give you kilometers per liter. But it also occurs to me that if I were a user looking at this, I might be able to interpret that this could go both ways. So, for example, I could convert in this direction, or I could convert in this direction, kilometers, liters, back to miles per gallon. Now, my original idea for the program was only to go in one direction from miles per gallon to kilometers per liter, but looking at this makes me think, maybe I should expand my original idea to make it go both ways. That way, someone else who's trying to go the other direction could do that as well. We'll think about that when we get into the actual implementation. Okay, so that was the first phase of planning, paper mock-ups, and this is what we resulted with for our miles per gallon to kilometers per liter converter. So the next phase is going to be working with flowcharts and pseudocode. So let's start with a flowchart. The flowchart is just a basic representation of what's going to happen in sequence as our program is run. So the first thing that happens is a user is going to start the program. They will, go to the start menu or desktop or wherever the program happens to be and start it up. And then the next thing that will need to happen is the program will need to get a miles per gallon indication from the user. Either they type it into a text box or something like that. And next, the program will convert the miles per gallon into kilometers per liter. Finally, the program will output the kilometers per liter so that the user can see it. And then if the user is not done, they can go back and enter another miles per gallon value, and it will go through the process again. But if they are done, then the program will exit. So you'll notice that I'm following the conventions for flowcharts here. Flowchart processes should start and end with an oval. Any steps that involve getting input or outputting data, getting input from or outputting data to a user are used with a parallelogram, and then the rectangle is a process. The diamond shape with the done in it is a decision point within our algorithm. So the next stage then is to go on to writing some pseudocode for our application. Pseudocode is not really code. It's basically English that you use to lay out the steps of your processes. In this case, the only part of our flowchart that actually needs to have pseudocode written for it is the box that says convert miles per gallon to kilometers per liter. So let's write up some pseudocode for that. The first step is going to be to create some constants to represent the liters per gallon and kilometers per mile conversion factors. These will be things that get used as many times as the user does conversions in the program. The next thing you'll need to do is make a variable for the miles per gallon and initialize it using the input from the form. And then you'll make a variable for the kilometers per liter variable, to which you will assign the value of the calculation, the result of the calculation of the conversion. Then you can output that for the user. Also, a good thing to have handy with us when we go to implement our application is the actual formula for calculating this conversion. In this case, kilometers per liter equals miles per gallon times the kilometers per mile, which is 1.61, times the gallons per liter, which is 0.264. So let's take a look at the next phase, which is documentation. Documentation is one of the most neglected phases of programming. Usually developers have the bad habit of not documenting at the time they're actually writing the code or even beforehand, and therefore once they get done writing the program, their energy for going back and writing in comments and other documentation that will help people maintain their program is somewhat reduced. And once you have a working program, it's hard to go back and make yourself do this. So it's important to try do this at the earlier phase in the programming. Why is it so important? First of all, writing the documentation out ahead of time forces you to think more clearly and therefore write better code. When you really think about explaining what's happening at each step in the program, you'll frequently uncover errors that you made in your logic leading up to the implementation. It also helps you decouple algorithm generation from code generation. An algorithm is in English. It's basically the series of steps that the program is going to accomplish. Most of us, even if we've never programmed before, can write a simple algorithm in English. For example, almost all of you could probably write out the steps that you'd have to follow in order to convert miles per gallon to kilometers per liter. The code generation, code is in code, and frequently the code you'll be writing is not going to be familiar to you. This is the same whether or not you've been programming for years or whether you're a brand new programmer. Most programs we write are new to us. The problems we're trying to solve are not problems we've tried to solve before, and so you have to do a lot of research at the coding phase, and so by documenting ahead of time, you can put your algorithm in English in the documentation and come back later and then focus solely on the code. So not having to think about both of those at the same time is a huge plus. Documentation also allows others to read and follow your code more easily. This is especially important for collaborative and or open source projects. You'll find that once you get into coding situations where you're working with another person or 2 people or 20 people or 100 people, being able to have them read your code and know what's happening is a really, really important thing. Also, you'll appreciate it when other people have gone to the effort to do this so that you can understand what they've done in their code. Documenting also allows you to read and follow your code more easily. It's very easy for us to forget the reasons why we wrote a certain line of code, and if you've got a helpful comment there, when you go back and look at your own code, whether it's the next day or the next week or the next year, if you've done the due diligence of putting that documentation in, you'll really be happy with yourself. And finally, documentation is important because it can help you earn the respect from your fellow coders and potential employers. When people look at your code, if they see that you are really good about documenting it, your esteem will really go up in their eyes. They'll say, wow, this guy or this gal really understands the importance of documentation, is very diligent and conscientious about putting in, and I promise you that that will pay dividends down the line. So now let's go to our program and put some documentation in. Okay, I'm starting a new project for my fuel efficiency converter. First I'll give it a meaningful name, fuel efficiency converter, and I will choose a directory for it. Click OK. And my project is up and ready to start. Let's open my Solution Explorer. And the first thing I'll do is rename the form. Call it FRM for form, fuel efficiency converter.vb. And we'll say yes to allowing it to rename all of the parts of that. Let's see, open up our properties here, and you'll see that the file name is it's called fuel efficiency converter. Alright, so here's my form, select that. And the first thing that I'll change is the name that's up here. Instead of form 1, we should give it something more appropriate like fuel efficiency converter. And now we can open up our toolbox, pin that, and we can begin adding controls to the form. I'm going to make the form a little bit bigger here so I have some more space. First thing we need is a label for the miles per gallon text box, and then we'll have a text box for the miles per gallon text box, and then we'll have a convert button, and then we'll have a label for the kilometers per liter text box, and then we will have the kilometers per liter text box. And we'll also put a label up near the top here for the instructions. So now we'll go through to each one of these controls and give them meaningful names. The instructions label we'll call LBL instructions, and then we'll go up to the text and say, please enter MPG in the box and press convert. Okay, and then for the MPG label, we'll call it LBL MPG and make the text MPG. Oops. And then for the text box next to it, we want it to be called TXT MPG. That will be the text box for miles per gallon. For the button, we will call it BTN convert, and we'll change the text on there to say convert. And then label 2, we will set the name to LBL KPL and set the text of that label to KPL. And then for the text box, we will set the name to TXTKPL. And that will get all of our names correct. So now let's take these things and move them so that they're in a better spot. Okay, now that we've got everything in a nice position, we'll resize the form to be closer in size to those things. Okay, so we've completed the look and feel for our form. We might want to move these guys over slightly more so they're about the same distance away from the button as the miles per gallon. Of course, you can spend hours tweaking the look and feel on this stuff, but get it looking nice. Okay, so it's fairly simple. You enter miles per gallon, you click convert, and the kilometers per liter should show up in this box. So let's go on to the documentation phase. To do that, we're going to be programming what happens when the convert button gets clicked. So if I double click the convert button, it will open up the click event for the convert button. So I'm going to close my toolbox here, close my properties so that I can see all of the code. And now we can begin our documentation process. Alright, so I'm going to start at the top of the file, and if you type 3 single quotes, then you'll see some of the automatic documentation features of the Visual Studio environment. So this creates an automatic set of fields here which can be fed into the documentation system if you ever wanted to make this code base available. So I'm going to type in here the name of the program, Fuel Efficiency Converter. The name of the file is FRM Fuel Efficiency Converter.bb. Morgan Benton. The date is 22 January 2011, and this is a program to convert miles per gallon to kilometers per liter. So by starting out this program with a short summary of what the program is about, then I've documented for whoever comes here what this file is when they open it. I'm going to go down here and do the same thing for my btn convert method. If I hit the single quote button 3 times, it creates some information for me, and I can say when the user clicks this button, the program will calculate the kilometers per liter based on the miles per gallon that was entered. Alright, so that should be enough for here. We don't need to specify any documentation for the sender and E parameters, which are here, because those are just default event parameters. Alright, so now we can begin writing out the documentation that we had in our pseudocode. So the first step that we said we would cover in this algorithm was to create constants for our conversion values. The next thing we're going to do is create variables to hold the MPG and KPL values. Next, we said we would, next thing we have to do is get the miles per gallon value that the user entered on the form, and then we can calculate the kilometers per liter based on the MPG value and the constants. And once we've done that, we can output the results back to the form. Okay, so this has taken care of the documentation that I needed for this program. So I will save it, and let's go back to our presentation. Okay, now that our documentation is in, it's time for the implementation phase. First of all, coding is always a learning process, and I emphasize this. Even for experienced programmers, every time you write a program, it's always the first time. And the reason is fairly simple. If software already existed to solve the problem that you're trying to solve, then you would probably use that software. So, for example, I'm not going to go out and write another spreadsheet because I could just use Excel. Excel is, on my computer already. I don't need to recreate that wheel. If there is software out there that does something like you want it, but not everything, then that's a situation where you might have to implement a project. And because of that, every time you implement a new project, it's going to be the first time that you've ever built a project that's like that. And so the coding process will always be a learning process. That's good news for those of us who really enjoy learning and exploring new things, because it means our job as programmers always is creative, and it always involves stretching ourselves and challenging our understanding of how systems work. You should always expect to spend about 90% of your time being stuck. I say this because I've been programming for over 10 years now, and from everyone I've talked to and from my own experience, you spend about 90% of your time trying to debug your program, figuring out what line of code to write next, why to write that line of code, figuring out why the code you've written doesn't work. You spend a lot of your time being stuck, and once you get unstuck, then you code frantically, madly until you get to the next place where you're stuck. If you knew how to do everything from the very beginning, the actual coding and implementation process would be actually pretty short. Sometimes you're lucky enough for that to happen, but most of the time we spend a lot of time figuring out what to do next. So what's important here is your friends. Who are your friends? First of all, Google is a huge friend. There is tons of information. Programmers pretty much live their lives online, and so they tend to put a lot of their information, their knowledge, into places where you can find it online. A textbook is a good friend to have when you are working with a new program. There's tutorials in there, step-by-step tutorials that break things down for people who are doing this for the first time, so get to be familiar with the chapters in your textbook and the things that they offer. You also want to get familiar with online documentation. For the .NET programs we'll be developing, the MSDN library is an invaluable resource. Don't be intimidated by the MSDN library. It's written for developers who are experienced, and so the information that's there may take you a little while to learn how it's presented so that you can use it effectively. But once you do, the MSDN library will be one of your best friends. Another one of your friends will be online forums. Stack Overflow is rapidly becoming one of the best places to get information on how to get past certain bugs, and going there and asking questions or searching through the answers that are there will frequently help you get unstuck. It's been one of my go-to resources for a while now. The Microsoft forums are also a good place to get answers to .NET development related questions. Your friends. Your friends are your friends, right? So your classmates, your TAs, upperclassmen, or other people you may know who have some programming experience, those are all people that you should turn to when you get stuck to help you get past that hurdle. One important caveat here is that when you use, your friends or classmates, make sure that they don't just tell you how to do what you need to do, but tell you why and explain to you the reasoning for doing it the way that they suggest, because you want to come away from this understanding the code better. And finally, of course, your instructor was also always a resource that you can use. Okay, so let's take a look at what the process looks like when we are implementing our miles per gallon to kilometers per liter application. So let's begin programming. First thing we need to do is create the constants for our conversion values. The way we do that is use the const keyword and give it a meaningful name. In this case, we're going to use decimal values for that, so I need to use DEC and then use all capitals for the name of the constants. The first one I need is the kilometers per mile, and as decimal, and we need to set a value of 1.61, and we can put a comment out here and say kilometers per mile, and then we need to declare another one. Const DEC gallons per liter as decimal equals 0.264, and we'll put another comment here that says gallons per liter. That should be enough documentation for people to understand in the future. And now we need to create variables to hold the miles per gallon and kilometers per liter values. Both of these are going to be decimal values, and so we can create them in one line of code. We'll say dim DEC MPG, comma, DEC KPL as decimal, and that takes care of creating those values. The next thing we'll need to do is, once people have entered a value on the form and they click the button, this function is going to run, so we should be able to get the value that they've typed into the form. So we'll say DEC MPG, and we'll set that equal to the value from the TXT MPG. That's the miles per gallon text box on the form. But the problem with this is that the value on the form is going to be a text value, right? That's the text box stores text, so we need to get the text property of that text box, but we need to save it as a decimal, so we need to convert the property in our text box to decimal. So I'm going to use the conversion function CDEC and wrap that around our value here. So that should convert whatever is in that text box into the decimal. Now we can run the calculation, and to do that we'll do DEC KPL, because that's the value that we want to set, and we're going to set that equal to the miles per gallon times the kilometers per mile times the gallons per liter, and that should do our conversion, set our value for us. And now we will send the output back out to the form. So we'll do txt kpl dot text, which will allow us to set the text value of that text box and set that equal to DEC kpl dot to string. And so that will convert the decimal value into a string, which is a text value, and put that in the text box for us. Okay, now that we have implemented our application, it's time for step 5, debugging and quality assurance. In this phase, we want to use and test our application to make sure that the output that it's producing is what we expect, and that it is, doing and behaving the things that we expect it to do. We want to figure out what's likely to go wrong. What are the trouble spots? What are the places where people could potentially put data into the application that might screw things up? We want to check the accuracy of our calculations and output by hand. So, for example, in the case of our calculator that we've just built, we'd like to actually take that input and calculate what the output should be, on paper or using a calculator, and make sure that our program actually produces the values that we're expecting to see. Frequently your application will give you an output, and if you just, blindly or naively assume that it's the correct output, you could be setting yourself up for a big problem. And finally, you want to work to make your application bulletproof. Bulletproof is the term we use to, when we are trying to say that no matter, what kind of mean, nasty, ugly things the people using our program try to do, it won't break our program, it won't cause it to crash, it won't cause any loss of data or loss of time or anything bad things like that. So let's go take a look at our application again. Let's test it out and see if everything is working correctly, and see if we can make some improvements that will make it more bulletproof to the user. Now we're ready to debug and test our system. So the first thing we can do is we can click on the Start Debugging button right here, and this will compile our project for us and start it up so that we can see if it is correct. Alright, so you can see the application here. Let's just test it out. Let's use my wife's car. She has a Honda Fit, and on a good day it gets about 33 miles to the gallon. And if we click convert, that says 33 miles to the gallon is equivalent to 14.02632 kilometers per liter. Now I don't have any idea whether that's correct or not, so I'm going to open up my calculator, pull my calculator over here, and let's try that out. I'll say 33 times 1.61 times 0.0264, and that equals 1.402. Let's see, it looks like we're off by a factor of 10. Let's try that again. 33 times 1.61 times not 0.0264, but just 0.264 equals 14.02632. Fantastic. It looks like our calculation is working out. We've double checked it. Let's see what other things we might be able to do to make this application not work correctly. What if I put in here, instead of 33, I put in 33 mpg? When I click convert, we have a problem. Invalid cast exception wasn't handled. Conversion from string 33 mpg to type decimal is not valid. I see what the problem is here. We're trying to convert the letters mpg into a number. Of course, Visual Basic is not smart enough to know that we didn't need to put those mpgs on there. Alright, well this is a problem because users might, I don't know, not often, but might try to put something else in that box besides a number. So let's modify our code to handle this exception and return a useful message back to the user in the event that they do something incorrectly. Alright, so let's go ahead and click stop to stop debugging. We're going to use a structured exception handling call here, and that means using a try block here and then catching the exception and try, And so what this will do, this will catch EX as exception. What this will do, this will try to convert whatever's in here, but if it doesn't work, we are going to be able to recover from that. What we'll do is we'll send a message box to the user and say the MPG value must be numeric. Please do not enter any non-numeric values into the box. Okay, and that will create an exception so that now hopefully our users won't be able to break our application. Let's test it out again and see if it works. Alright, so let's try putting in our value again, 33, MPG, click convert. The MPG value must be numeric. Okay, I see that. Oh, but now it's still outputting the KPL as 0. We need to fix that as well. Alright, let's add a couple of other things. Let's stop debugging. And first of all, let's say that after that message box gets shown, let's clear both of the boxes. Let's do txt mpg.clear. That will clear that box. txt kpl will clear that one as well. And then we'll put the cursor back in the miles per gallon box by calling the focus method on that one, and that will put that back in that box right afterwards. And then we don't want it to run any more code in the method, so let's just return. Okay, and that will make us quit this whole method without executing these two lines of code down here. Alright, so let's try one more time. Here is our converter. Let's put in 33 MPG and click convert, and it says the value must be numeric. Please do not enter non-numeric values in the back. We click OK. It clears the box and puts the cursor right back in there, so we can type 33 now and we can hit convert, and it gives us our value just like we expected. Excellent. We can do something else. We could go to, for example, my 1998 Dodge Caravan with 163,000 miles on it, put in the 14 miles per gallon it gets, and see that that's less than 6 kilometers per liter. Okay, so that looks good for testing and quality assurance. Okay, now that we've taken the care to make sure that we have a high quality application that's bulletproof, it's time for the release and deploy step. And this is where we will convert our application into an installable package so others can use it, and then find a way to distribute it. And now for the last stage of the process. We've got our completed application and we're ready to deploy it so that other people install it and can use it on their systems. So in order to do that, I'm going to go into my Solution Explorer, right click, and select Add, New Project. From the list of templates here, normally I've got the Visual Basic window open. I'm going to come down to Other Project Types. Under that there's Setup and Deployment, and then there's Visual Studio Installer. In the list of projects here, I would like to select Setup Wizard. I'm going to name this Fuel Efficiency Converter Installer. And then for the location, I'm going to select the same folder in which the Fuel Efficiency Converter project is stored. And then I'm going to click OK. And it starts a wizard for me. This is the Setup Project Wizard. I'll click Next. And I want to create up a setup for Windows application. It says which project output groups do you want to include, and right now all I want to include is the primary output from the Fuel Efficiency Converter. That would be the executable that was built by the project. Click Next. And the additional files, nope. Click Next, and there's a summary, and I click Finish. Okay, so you can see that another project has been added here to my fuel efficiency converter solution. There's the main project, and then there's the installer project. So what I need to do now is I need to go to the application folder, and you can see here that I've got the primary output from the fuel efficiency converter. Now if I would like to create shortcuts to that, for example on the desktop or in the user's programs menu, I need to right click on that, select create shortcut. I'm going to name my shortcut fuel efficiency converter, and then I'm not going to create one on the desktop for this project. I'm just going to create one on the user's programs menu. I'm going to drag that fuel efficiency converter to the user's programs menu. Now if I click on the user's programs menu and look down here in the properties, I need to change this property always create and change that to true. Other than that, if I click here on the fuel efficiency converter, you can see that the target is the primary output, that's the executable, and then that's going to be stored in the user's programs menu, but it's going to point to the application folder where that is stored. If I click on the fuel efficiency converter project here, you can see that I get a bunch of other properties for the program. So I can change some things like the author would be myself, and I could put a description for the project, which is a simple app to help people convert MPG to KPL. And I want to say install for all users. By default we'll say true, so that when people install it, everybody who's on the machine will be able to use it. The manufacturer, we'll call that ISAT 252 Incorporated. The manufacturer URL, let's put our course website there, http ISAT 252 spring 2011.umatter2.us, and you can put other information here. This is version 1.0.0, and we should be good from there. You don't have to fill in all that stuff unless you really want to. Okay, now that we've done that, we can right click on our project and click build. And you can see down here that build 2 succeeded, or up to date, 0 failed or skipped. And now we will change to the folder where we now see 2 projects. One is the main program folder, and one is the installer. Let's go into the installer, go into the debug folder, and you can see now that I've got the fuel efficiency converter installer.msi. If you want to rename that, you can if you'd like, but this is an MSI file that if I clicked on it would install the program. So let's go ahead and do that. I'll click on that and open up another window, but I'll pull it over here. Welcome to the fuel efficiency converter installer setup wizard. I'm going to click next. It'll ask me where I want to put this. I will put it in the ISAT 250 fuel efficiency installer directory. Want it to install for everyone. Click next, and it's ready to install it on your computer. I'll click next, and you can see that it is now installing the files, and it's been successfully installed, and you can close that. Now if you want to check, you can go to your your local C:, look in program files, and you can see there's a folder called ISAT 252 Inc. And if inside of that there's a fuel efficiency converter installer folder, and inside of that there is the actual executable file. You can't see it because it's not on the screen, but if I go to my start menu and look in all programs, I'll see a link to fuel efficiency converter, and I'm clicking it now. And when I click it, the actual application comes up as an application on my computer, and I can type in the data and see that it does its conversions, close it just like I normally would, and I have a fully deployed application. All you have to do now, if you want other people to be able to use your product, is to take that MSI file, and which was in my documents, teaching, ISET 252, spring 2011, prof, which was in this folder here. Just take that MSI file and put it in a place where people can download it, maybe on your website, or you can try emailing it to people, although some spam filters might filter out the executable from the email. But you can see that it can be distributed now, and you have come full circle. Okay, so there you have it. There is our application. We've gone all the way through the 6 steps, from ID generation to planning to documentation and implementation, debugging and quality assurance, and finally we've created a releasable package that anyone can use. I hope it's been useful. Please feel free to ask questions if you have them.